Okay, we're going to solve different type of equation today. We're going to do 4 examples. The reason there are 8 because the second page is just like the first page. You have 2 problems at the end to do. Okay, now you might get some bizarre looking answers, and that's okay. Okay. Now we have 4 to the power of 2x minus 5, and then 4 to the power of 3x. So I have to solve for x, and again, x is obviously within a power. So the first thing I should be doing is parenthesize the base and the power. Sorry about the staple being in your way. But I never had this when it's on both sides, so you're not going to be able to do the COB. Okay, that only works when that's going on one side. That was a previous day's assignment. Okay, here's what you need to do instead. That's your base. That's your base. What you're going to do is take your larger base, or excuse me, that didn't make any sense, excuse me. Take your larger base, 64, yeah I did, that did make sense, 64, the larger base. Now take the smaller base and start multiplying it, and hopefully we can get it to equal 64. Big emphasis on hopefully, okay. So here's a 4, obviously not there, that'd be 16. How about a third 4? Would that take me to the 64 I'm trying to get to? Indeed. Okay. Now, after you figure that out, put equals 4 to the third power, because there are 3 4s. Now, what you're going to do is replace that 64 with 4 to the third power. So this stays the same. Okay. This 64 is replaced with 4 to the third power, 4 caret 3. Then you make a parentheses and put the original exponent. Now if you're wondering what the point of that was, well now that the bases are the same, they can be canceled. They're equal. So you take this 2x minus 5, then you have to take the 3 times the 3x, okay? And that's going to be 9x. Now it's just a linear equation you can solve, okay? You've got it out of its power. So if you have a power on both sides, you're not going to go for this change of base, like you're not going to go for the COB. You're going to try to make it from a power to a linear equation by making the bases the same. Okay, so get rid of one of your x's. You're using linear properties because the x's have no powers. They'd be to the first power, okay? So linear properties. And then minus 2x from 9x, so negative 5 equals 7x. Divide by 7, just put that as negative 5/7. Okay, if it doesn't divide into a perfect whole number, I would just keep it. Okay, next one. 7 to the power of 3x plus 4 equals 49 to the power of 2x plus 1. So I'm solving for x, and again, x is a power. So, parenthesize the base and the whole exponent. And no, you don't need to cut it or anything like that. That's what you do when you're graphing. Obviously, we're not doing that. Now, we want to turn it when it's on both sides like this. Instead of doing change of base, which we're not able to do, we lose the ability to do that. Okay, using the log over log cannot be done when it's happening on both sides. You want to get the bases to match so it goes from power to an equation where I can just apply the linear properties. Okay, so take your larger base, 49, and start multiplying the smaller base until you hit 49. It doesn't take long. 7 times 7 is 49. So this is equal to 7 to the second power. Okay, so we replace 49 with 7 to the power of 2. So where the side with the 49, I replace with 7 to the second. And then I need to make a parentheses and put the exponent that was there originally. Now over here we want to keep it at the base of 7, 3x plus 4. Okay, now cross out your 7's. Okay, now they're canceled. Now it goes to a linear property equation. So you have 3x plus 4. Then on the other side, you have to apply the distributive property, 2 times 2x and 2 times 1. So 2 times 2x is 4x, and 2 times 1 is 2. I'll have a lot of people, for whatever reason, just keep that at 1. No, you have to take 2 times both of them. So linear properties, first off, you just get rid of one of the x's. Don't move everything to one side. That's not linear, that's factoring properties, okay? Just take an x out. I know there's been a lot of equations where we've cleared one side of the equation. That's when you have x second and x to the first, or x sets to multiple powers. Here we just have x, nothing but x to the first power. So it's 1x plus 2. Now I get rid of the plus 2. It's 2. Divide by 1, it'd just be 2. So 2. You can get some pretty weird decimals. You can just keep them as fractions. They look weird. Now I'm going to do a couple oddball problems. First off, you can't read what that says. That's a 1/6, okay? And this is 11 minus 1x, okay? Now, we want the bases to be whole values. Right now, that's a fraction value. Well, I could make that a 6 over 1, which is the same as 6, if you switch the exponent to its opposite. So the 11 would go negative and the 1 would go positive. Now you can do it just like you've been doing it. So again, you're solving for x. And again, x is in a power. So to find the next move, we need to apply the power symbol. Put those in parentheses. Nothing going on outside, but we can't do COB because it's on both sides. So you got to make the bases so that they match up. Okay, so take the larger base and multiply the smaller base times itself till hopefully you reach a product of the larger base. 6, that's not good enough. 6 times 6 is 36. Okay, so stop there and you write equals 6, and there are 2 6's, so it's 6 to the second power. So replace that 36 with 6 to the second. Okay, some of you are like, does that be negative 2? No, I did the negative thing when I switched the signs. So replace that with 6 to the second, and a parentheses with 5x plus 2. Caret, and we have a 6. Caret, negative 11 plus 1x. Okay. All right, now we're good. 6 is see ya. Okay, so I have to distribute my 2, and that's 10x. Make sure you're taking 2 times 2 as well to get 4, and then that's just going to stay 11 plus 1x. So take out one of your x's. I usually do the smaller one because it's just a simple linear equation now. So 9x plus 4 equals negative 11. 9x equals negative 13. That division is going to be a decimal, so I'm just going to put negative 13 ninths. Or negative 1 4 ninths if you want to get particular. Now, this one's a little bit odd. I don't think I put one of these on the assignment. Okay. So you have 27 to the power of 4x minus 1 equals 9 to the power of 3x plus 8. Okay? So again, you're solving for x, and the x variable that I'm solving for is within the power. So again, you want to put the base and the power in parentheses. You don't have any operations outside, but you can't do the COB. Now, if I just had this with, like, instead of that crap, if I just had an 81 there, I could easily do COB, but I don't, okay? So I take my larger base, and now we run into a problem, okay? Take your 9. 9 times 9 is 81, so this is impossible. Cross it out. Here's what you would do at this point. You would put your bases, line them up. You would try to rewrite those as a base exponent where the bases are the same. You're like, well, how do you do that? Very easily. You'd go to your root sheet. Some of you might know, but so 9/27. Well, here's 9, and that's 3. Okay, so I'm going to write 9 equals 3, and since that's on the to list, it would be 3 to the second power. Now, hopefully there's somewhere where 27, a radical over 27 would equal 3, and right there it does, okay? The cubed root of 27 is equal to 3 because 3 times 3 times 3 is 27, okay? So that's 3 But since I'm on the cube list, it would be 3 to the third power. Now, we've replaced the 27 with a 3 to the third, and then a parentheses, caret, parentheses 4x minus 1. You replace the 9 with a 3 to the second, and a parentheses with 3x plus 8. Okay, that's how that's going to work. Alright, then the 3's can go bye-bye, and I'm going to have to distribute on both sides. So 3 times 4x, 3 times negative 1, that's going to be 12x minus 3. And over here it's going to be 6x plus 16. Take out your 6x. That's 6x minus 3 equals 16. Then I plus 3 plus 3. I'm at 19. Divided by 6. You can leave that as 19/6 because it's not a whole number.